Another type of reaction, oxidation-reduction. These are sometimes, we sometimes shorten the name because oxidation reductions are a lot of syllables to say, and we call it a redox reaction. It looks a little like red box with the B missing. Redox, because I think ox-red just sounded dumb, so they redox. Redox reactions involve transfer of electrons. So one substance is losing electrons, the other is gaining. I think of electrons as a little bit like, being a baby, right? You don't just put a baby down on the sidewalk and walk away. You hand the baby to someone. Electrons are teeny, teeny, tiny things, and they can't be out by themselves. So they're passed from one substance to another. So if there's something that's losing electrons, something else must be gaining electrons. Redox reactions are really, really important. When iron rusts, that's a redox reaction. If you get your hair bleached, that's a redox reaction. Batteries. I think we're all using batteries right now. There's a battery in my iPad, there's a battery in my cell phone, right? Batteries. Batteries involve redox reactions. That's how the electricity is produced. A lot of these redox reactions involve the reaction of a substance with oxygen. Not all of them, but many of them do. So here are a couple examples. This is what happens when iron rusts. Iron reacts with oxygen and it forms iron 3 oxide, which is rust. The combustion of natural gas. It's a combustion reaction, it's a burning reaction, but it's also an exchange of electrons. So anything burning, anything reacting with oxygen is going to end up being an oxidation-reduction reaction. So we need to understand what oxidation is and what reduction is. And it's all about the electrons. So oxidation is the loss of electrons, and reduction is the gain of electrons. So to remember that, you can just remember oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. Oil rig. They have to occur together. If one substance loses electrons, another must gain electrons. And all we're going to do right now is to be able to identify redox reactions. Redox reactions end up being somewhat complicated. So we're just going to learn to identify them. How do we identify them? If we see a substance reacting with elemental oxygen, like the combustion of methane, something plus O2, that's a redox reaction. If we see a metal reacting with a nonmetal, that's a redox reaction. They're going to form an ionic compound. How do they form an ionic compound? They have to become ions. When a metal becomes a cation, it does so by losing electrons. Where do the electrons go? They go to the nonmetal, who became a negative ion by gaining electrons. Transfer of electrons, redox reaction. And just in general, anytime you have a substance transferring electrons to a different substance. So which of these are redox reactions? Number. Letter A. What do we have here? We have lithium reacting with chloride. That's a metal and a nonmetal reacting. Is that a redox reaction? Yes, it is. Excuse me. Come on, I want to drop. So this is redox. How about this one? What's going on here? Here we've got aluminum with no charge. That's aluminum metal. And what is it over here? It's an aluminum ion. How did it become an ion? Transfer of electrons. Is this a redox reaction? Yes, it is. How about this one? Is that a redox reaction? Does it fit the criteria we saw in the previous slide? No, it doesn't. And if we look a little more closely, I mean, we've studied reactions like this. This is a precipitation reaction, right? Two ionic compounds that are soluble, and we're getting one insoluble compound and another soluble compound. This is lead 2 ion. This is lead 2 ion. This is nitrate, and there's nitrate. Here's lithium ion and lithium ion, chloride ion and chloride ion. Nobody changed charges. It's not a redox reaction. How about this last one? Yes. Reaction with oxygen. That's all you need to. That's all the farther you need to go. Any questions? What we're doing in lab today is going to be a redox reaction.